everyone. In the previous lecture, we have already discussed about the enzyme action, the catalysis, and the types of catalysis. Let me rewind a little bit. So let me give a brief information about enzymes, what we learned about. Enzymes are the complex nitrogenous organic compounds which are produced by the living plants and animals. They are very effective catalysts. Okay, then what are catalysts? First, you have already studied, but still, substances which accelerate the rate of chemical reaction and themselves remain chemically and quantitatively unchanged after the reaction are called catalysis. Okay, now let's move on to the application form. So this is the image of the enzyme action, in which the green part is the enzyme and the above part is the substrate. And what happens in the enzyme action later on is they get combined and then they move on just like this. See, in this what's happening is, this is a working formation of enzymes. First, enzyme and substrate gets connected, and that is the site which they are going to get connected is called as active site. Next process is enzymes and substrate complex are combined together. Okay, the third stage is the product is changed. Like what happening is, some of the effects of the enzyme are being transferred into the substrate, means the message has been carried by the substrate from the enzyme. And the last step, which is the release of the product from enzyme substrate. All right, so what's happening is, the substrate has now received the message from the enzyme and now they are disconnected and they are out of the enzymes now. So this is actually the working procedure of the enzymes, and this is how they fastens the reaction and speeds up the chemical reaction. And you can see over here the enzyme is completely unchanged. Even after reaction, they are not having any kind of deficiency. They are completely fit and fine in the same way they were in the first stage to the last stage. Okay, now let's move on to the next, and that is types of solutions. So first one is, what are true solutions? We often try to understand in our kitchen or something what happens with us, how are the daily phenomena are related to the chemical science. So this is one of the examples. First one is true solution. True solution is actually a homogeneous mixture. As I already told you, homo means one, so mixture turns into the complete singular form. All right, then the diameter of the particle is less than 1 nanometer and it passes through the filter paper. It means that they are not having any difference in the two particles which are already mixed into the solution. All right, so its particle cannot be seen under a microscope. It means that it is so well mixed. So that solution which is not having any difference between the solute and the solvent, that is called the best solution or the true solution. All right, now next one is colloids. What are colloids? So let's understand that. It appears to be homogeneous but is actually heterogeneous. Okay, the diameter of the particle is 1 nanometer to 1000 nanometer. It passes through ordinary filter paper but not seen through ultrafilters. Its particles can be seen by powerful microscopes due to scattering of light. So by this you can surely understand that when we were at true solutions, their particle could not be seen by the microscope, which is the strongest power of the lens. Okay, so true solutions part could not be seen, but in colloids it can be seen with the help of a microscope. All right, so, and also you can also differentiate, like in true solutions the particle's diameter was less than 1 nanometer. Okay, that is why it was completely mixed. And then when we came to colloids, its diameter of the particle is 1 nanometer to 1000 nanometer, means it is always more than 1 nanometer, so it can be seen with the help of a microscope. Now the third point is suspension. So what is suspension is, it is a heterogeneous. The diameter of the particle are larger than 1000 nanometer. So are you seeing the variations? For the true solution we were having less than 1 nanometer. For colloids we had 1 to 1000 nanometer. Now in suspension it is more than 1000 nanometer. Okay, so it is quite larger particles than the colloids and the true solutions. It does appear through the filter paper. Of course, if it is larger than 1000 nanometer, it can be seen through a filter paper. All right, and the particles can be seen even with the naked eyes. We don't need a microscope for it. We don't need a filter paper just to identify the difference between the particles. We can use our eyes, and but through the eyes we can see the size of the suspension. Okay, so two important points in that are dispersed phase and dispersion phase. So dispersed phase is, it is the substance which is dispersed as very fine particle. Okay, and the dispersion is, it is a substance present in larger quantity. Okay, so you can understand well by the word very fine particle and the larger quantity means dispersed phase, and that particles are very small and very fine, which they cannot be seen properly. But dispersion medium has a larger quantity, so in dispersion medium we are able to see the difference between the properties of the solution. All right, so these were three types of true solution, colloid solutions and suspensions. Let's have a summary of it. That is, the true solution is the homogeneous mixture, while colloid solutions and suspensions are heterogeneous mixtures of two or more substances. Another difference between these three types of solution is that true solution is transparent, while the colloidal solution is translucent and suspension is opaque. It means that in the true solution we can see from one side to another directly without any disturbance. Okay, then coming to colloidal solution, that is translucent, means half we can see. When the light is put on it, it scatters, so there is a disturbance and image formation has a problem. But in suspension is completely opaque, we cannot see from one side to another, nothing at all. All right, these were the summary of the three kinds of solutions. Now coming to the next, and that is, this is the classification of colloids on the basis of physical state of dispersed phase and dispersion medium. This actually has to be learned. You can also understand the examples in this. When we have solid solutions, in that what happened, dispersed phase and dispersion phase, solid and solid, both of them are solid. So color, gem or stones, anything, that is example of a solid solution. Then coming to the solution in which one is solid, one is liquid. For example, paints. Alright, so solids and paints, these are dispersed phase and dispersion phase. So example is a paint. Then aerosols. Aerosols in dispersed phase is solid, and dispersed phase is solid, and then dispersion medium is the gas. And then for example, what is it? Smoke or the dust, anything which is visible to us. Okay, then coming to gel. Gel is what? Solid and liquid. In dispersed phase it is liquid, and dispersed medium it is solid. So it is like cheese or any kind of jellies which we can see. All right, then what is happening? Immersion. In immersion, what is it? Dispersed phase is liquid, and then dispersed medium is also liquid. So what is happening is, for example, hair cream and the milk. So these are, in both the phases they are having liquid state. Then aerosols we have already discussed, and there are some more examples for aerosols. Is when we have in dispersed phase it is liquid, and when the aerosol in dispersion medium is gas, then it is mist or fog or cloud. Alright, then solid solutions, when in dispersed phase it is gas, and in dispersed medium it is solid, then it is foam rubber or pumice stone. Okay, then foam. In foam, what's happening is dispersed phase is gas and dispersed medium is liquid. Then what is it? Whipped cream. We can have, for example, when we make that egg albumin, for cakes and all, that is also kind of whipped cream. And also we have milk whipped cream. So it is quite means that liquid is very spongy kind of inside. All right, so that is foam. Now this is the classification of colloids on the basis of nature of interaction between dispersed phase and dispersed medium. And the colloids are classified into two types, namely lyophilic solutions and lyophilic. Okay, so lyophilic solutions, what's happening? In lyophilic solutions, what's happening? We will see here. See, this is the lyophobic solutions. By the word, you should understand that if it's talking about phobic means something which is scared of or going away. All right, and philic means something coming nearer or used to. like that. Okay, so in leophobic, it is these colloids are liquid hating. It means that they will not come to the liquid. All right, in these colloids, the particles of the dispersed phase have no affinity for dispersion medium. They are not stable. They can be prepared by mixing substances directly. They need stabilizing agents for their preservatives. Also, they are irreversible solutions. So leophobic, you may directly understand that they will not be coming nearer to the solution. They will be going away. And now we have here leophilic solutions. In this, you can see here these solutions, these colloids are liquid loving, and in these colloids the particles of dispersed phase have great affinity for the dispersion medium. They are stable, like you could see here. They are not stable. Leophobic are not stable and leophilic are stable. They cannot be prepared by mixing substances directly. They are prepared only by special methods that we'll discuss in later lectures. They do not need stabilizing agents for their preservation. They are reversible solutions. You can also differentiate between these, like leophobic solutions are irreversible and leophilic solutions are reversible. Okay. Now, summarizing them in this picture is, you can see these are two of the images. In this, leophilic solutions are outside H2O molecules surrounding the substance. Okay. These are leophilic colloids. It means they want to come closer. Okay, and now what's happening is leophobic colloids. In leophobic colloids means they are water hating. It means they will not go closer to the H2O atoms, molecules. Okay, so what is happening is these two are different, and it can be easily understood with the help of this diagram. So leophilic is going nearer or water loving, and then leophobic is water hating. So that's all for today's lecture, and I think you would have understood the topic well. If you would have understood, just let me know, and if you have any doubt, just get back with the question to me, and I hope to see all these concepts into your brain. Thank you so much.